Bristol Community College, Mathematics with Dan Avedikian, Math 132, Calculus with Applications, Section 11.4, Problem 6. This is Section 11.4, Problem number 6. It says use the formula f prime of x equals the limit as h approaches 0 of f of x plus h minus f of x over h to find the derivative of the function 2x squared plus 3x plus 2. And once you've found that answer, part A, find the slope of f of x when x is 3, and part B, find the slope of f of x when x is negative 2. So first, let's find the f prime of x using the formula that's given, which I have written here in a couple of different colors. We have f prime of x equals the limit as h approaches 0 of, in blue I have written f of x plus h, minus, then in red f of x over, and then in green just h. So most of the work is finding f of x plus h. That's in blue, so off to the side in blue, let me do that work out and see what we get as an answer for that. The f of x in red is easy. The h in green is the easiest. So the question tells us that f of x is 2x squared plus 3x plus 2. That's given right in the question. And now for the blue part of my difference quotient formula, I want to use x plus h as an input value. So f of x plus h equals 2 times x squared becomes x plus h in parentheses squared. 3x becomes 3 times x plus h in parentheses. And the plus 2 on the end just stays a plus 2. Now again, that's the answer, but it needs to be simplified. That's the answer for f of x plus h. So f of x plus h equals 2 times x plus h second power is x plus h in one set of parentheses times x plus h again in a second set of parentheses. And now the 3 times x plus h in parentheses is no second power, so I can just distribute the 3 in there. 3 times x is 3x, 3 times h is 3h, and the plus 2 on the end just stays plus 2. Now, the first set of parentheses with the second power had the 2 in front. I cannot deal with that 2 until I take care of the second power. That's from that order of operations with the please excuse my dear Aunt Sally. You have to do exponents before you can do multiplication. So let's deal with this FOIL now and continue the simplification that way. So f of x plus h equals, there's going to be a 2 in front of the answer for the FOIL. So now I have x times x is x second power. X times h is hx. H times x is hx. And then h times h is h second power. And I'll close the parentheses because, again, there's a 2 in front of that. And the 3x, I can just keep. The 3h, just keep that. The 2, just keep that. So, and I can combine these like terms. F of x plus h. Let me keep the 2 in front just for one more minute. X squared plus hx and another hx is 2hx. And I have an h second power. Close up the parentheses. So 3x, 3h, and 2 just stay the way they were. Now, to finish my simplification, I have a big set of parentheses in this with a 2 in front of it. So I'll multiply the 2 in front times each piece in the parentheses. And when I do that, what will happen? I'll have f of x plus h equals 2 times x squared. I'll just do it in a different color, make it show up a little bit better, is 2x squared. Then 2 times 2hx will be 4hx. 2 times h to the second power will be 2h second power. And then plus 3x plus 3h plus 2. So now that is what f of x plus h is equal. All that work in blue can get plugged in for the blue part of my difference quotient formula. And the red part and the green part will be much easier. F of x, f prime of x equals the limit as h approaches 0 of. So now in blue here, we will have 2x squared plus 4hx plus 2h squared plus 3x plus 3h plus 2. So all of that blue is equal to f of x plus h. That's the work that we did. Now the rest will be much easier. So we have minus, right there, minus f of x, which is given in the problem. F of x is given. It's 2x squared plus 3x plus 2. So when I subtract off f of x, it's going to be minus 2x squared plus 3x plus 2. Now, as I've mentioned in previous problems, when you're subtracting off that f of x, make sure to use parentheses so that you're really subtracting off all of f of x. And then in the denominator, we just have an h. And I'll close the brackets. And that's what we have to take the limit of as h approaches 0. And as with these others from this section, the problem is the h in the denominator. If I didn't have that h in the denominator, I could just start putting in zeros for h and see what would happen. But what would happen when I have an h in the denominator is the answer is undefined. So the process is to cancel whatever does not have an h in the numerator. Everything left behind after you cancel the things without an h will have an h. You factor it out to the front and cancel the one in the denominator. So let's do that. So first, 2x squared, and if I look over here, here's a 2x squared. The one in front is a positive 2x squared. The other one in red parentheses, you're subtracting it. So positive 2x squared, negative 2x squared. We'll cancel those. Now the next piece, 4hx. It has an h, it'll stay. There's no other 4hx's that will cancel with it. So let me come off to the side and start what I have here. So off to the side, let me write f prime of x, the derivative, equals the limit as h approaches 0 of, so I'm going to have a 4hx squared. Oh no, 4hx to the first. Then plus 2h squared. The 2h squared has no other h squares that it will combine with. 2h squared. And let me cross these pieces off as I use them. So here's a 3x. There's no h, so I need to cancel that somehow. So here's a 3x, here's another 3x. Now the first 3x that I see is positive. The second 3x that I see, because of the negative that's in front of the parentheses, is negative. So positive 3x, negative 3x. Now, the next piece of my difference quotient, 3h. It has an h. It can stay in the numerator. There's no other 3h that it will combine with. So plus 3h. This 3h cancels. Oh, no, plus 3h. It's the 2 that cancels. Positive 2. This says positive 2, but again, because of the negative, there we go, 3h. So everything's canceled on the numerator or has an h in it. And then I have an h in the denominator. Make some brackets. So again, my goal is to take the limit as h approaches 0. I still have an h in the denominator. But now every piece left in my problem has an h in the numerator. So I'm going to factor that out. So I'm going to go f prime of x equals the limit as h approaches 0 of, so what I'm going to do is set up some parentheses with an h in front. So now the first piece, 4hx, becomes 4x when I take the h in front of the parentheses. The 2h to the second power becomes 2h to the first power when I take an h in front of the parentheses. The 3h on the end becomes just 3 when I take an h in front of the parentheses. And I still have this h from the denominator. Now, the h from the numerator that I factored in front can cancel with the h in the denominator. And now what I have is f prime of x equals the limit as h approaches 0 of 4x plus 2h plus 3. Now, I have no more h in the denominator. So the h that's left, I can let that run down to 0 and see what will happen. And what I get is f prime of x, when I do the limit, equals 4x plus 2h becomes 2 times 0 plus 3. And the 2 times 0 really just goes away. And what I have is f prime of x equals 4x plus 3. That's the derivative. This little equation, f prime of x equals 4x plus 3, will tell me the slope at any point on the graph of the function without even seeing what the graph looks like. So going back to the original question, part A said find the slope of f of x when x equals 3. So when x is 3, what's the slope? So what I would do is take my f prime of x that I found and put in a 3 for x. F prime of 3 equals 4 times x is 4 times 3 plus 3. So 4 times 3 is 12 plus 3 more. The answer is 15. So for part A, find the slope of f of x when x is 3. When x is 3, the slope is 15. And then part B, again, start with the answer we got for f prime of x, which was 4x plus 3. And part B says find the slope when x is negative 2. So again, this little equation will tell me the slope for any value of x, including negative 2. So f prime of negative 2 equals 4 times x becomes 4 times negative 2 plus 3. So 4 times negative 2 is negative 8 plus 3 more is negative 5. So at the point on the graph with an x value of negative 2, the slope at that point is negative 5.